All right, so here's the assignment I'd like you to work on for the remainder of the period. I'd like for you to explore H-NMR spectrums, and I'd like for you to create certain molecules that meet a certain criteria. So firstly, I'd like for you to create two different molecules, both of which that only have one hydrogen environment. Then I'd like you to create three different molecules that have two hydrogen environments, and so on and so forth. Now, lastly, the criteria you're going to meet is the specific spin-spin coupling on that molecule. Now, as you do this, please record the information that you find on a separate piece of paper. This will count towards your unit homework assignment. Please record the full Lewis structure, including all those hydrogens. Please label the hydrogen environments in some way. Differentiate one environment from the other, which ones are identical, and how many there are in total. Please draw the NMR spectrum for that structure. Draw it carefully, please. Also, please label the splitting that is present. Now, you're going to go to this link on your computer. Type in goo.gl/T lowercase k, b, capital L, lowercase x, 9. And when you do, it takes you to this website. Now, if it doesn't already, you're going to want to click to predict H-NMR. And firstly, we're going to be looking in this box here where you can draw structures. And a structure might pop up initially, it might not, I'm not sure. But one button that's really useful is the X button. And this lets you delete certain parts of the structure that you don't want anymore. So I'm going to start from scratch. One thing you can do is start by telling it you want a carbon. And you'll notice that it auto-populates with the hydrogens needed to meet the octet rule. Now from there you can add bonds to it. So say I want to add a bond there. Maybe I want to add another bond here. You can tell it that you want an oxygen present if you want. It automatically populates with what is most stable for the oxygen based on the bond present. You can change a bond to a double bond if you want to. I'm going to keep this molecule simple though for purpose of demonstration. So let's add one more bond in here. Now notice that it highlights where I'm adding the bond. If it's a square, I'm adding it to the molecule. If it's on the bond itself, then I would just be adding a double bond or a triple bond. So be careful about where your mouse is placed. So here, let's take a look at this spectrum here. Once you think you have the molecule you want, click Calculate Spectrum. What it's going to do is automatically show the chemical structure with the hydrogens present. Hello, I don't know why it's not working. Okay, I'm not sure what is wrong with this structure, but when I add another bond to it, it does work. So here we see the Lewis structure with the carbons expanded, and you can see that there are quite a few that are all in the same environment. Here, down with the NMR spectrum, is what we're really interested in. So here we get one big peak, and when you look very closely, and to see this closer, you can press this little expand button to show it full screen. It'll expand the spin-spin coupling, and you would see that this indeed is a singlet that has 12 hydrogens in it. You can see the integration trace. So that's how this works. You can copy the NMR spectrum. Make sure that you do a careful job about representing the singlet or the doublet or the triplet, that you copy the Lewis structure nicely. Please write in the carbons rather than using the skeletal structure form. And I want to see all the hydrogens present. So again, your assignment is 2 molecules with 1 hydrogen environment, and please don't reuse the one I just used. 3 molecules that have 2 hydrogen environments, 2 molecules with 3, 2 molecules with 4, and 1 molecule that has a triplet and a sextet. So that's 10 different molecules I want you to find. So good luck, have fun. I will see you later. Thanks, guys. Be good to the sub. All right, bye.